Hello everyone, welcome to day 14 of Leetcode May challenge. Today we have question number 743, network delay time. So in this question they have given us a network of n node labeled from 1 to n, and we are also given times, a list of travel times as directed edges u, v and w, where u is the source node, v is the target node and w is the time taken for a signal to reach from source to target. And we will send a signal from a given node k, and we have to return the time it takes for all the n node to receive the signal. If it is impossible for all the n nodes to receive the signal, then it will return the answer -1, otherwise it will return the total time taken. So in this example, this is the directed graph where the total node is 6 and the source node is 3. So from 3 we will give the signal, and we have to find the total time it takes for all the n nodes to get that signal. So first thing is, here we will create a variable total time which is initialized with value 0, and we will create a visited array which will keep like which all the nodes are visited and which are left. So this will be of same size as of the node 4, 5 and 6. So first thing is, first we will create a mapping of the node and to its connected nodes. Like 3 is connected, 3 it's directed with 4, like from 3 we can go to node 4, we can go to node 5, we can go to node 2. So that is what we will create a map. Like from 3 we can go to node 4 with a distance of 1, or the cost we can say, or the time we can say of reaching the signal. From 3 a signal can reach to node 5 with like, and the time it will take is 2, and from 3 the signal will reach to node 2 and the time it will take is 1. Similarly, for node 4 the signal can reach to node 5 and the time it will take is 1, and there is no other node to which signal is to from like which 4 is directed to. So yeah, now we will take the node 5. From node 5 we can send signal to node 1 with a distance 1, and then we have node 1. From node 1 we can give signal to node 6 and the time it will take is 1, and from 6 we cannot, it's doesn't have any node to give signal, and neither 2 is also not having. So this is what we got the mapping, and now we will create a priority queue, and the priority queue will be based on the minimum distance or the minimum time. Here I am using the word distance. So first thing is, we will add this is our source node, we will add a source node, and if the source is also 3 and the destination is also 3, so the signal will take 0 time to reach over there. So that's why its distance is 0, and we are using the BFS traversals. We are traversing in the level by level, like first 3, then 2 and 4 and so on. So that's why first we will pop this 3, and then we will check the maximum distance, or we can say time or distance. So I'm using the word time. So this is also 0, this is also 0, no need to update, so the maximum will become 0. And once the 3 is visited, now we will add all the nodes that 3 are connected to, like 2, 4 and 5, and we will, as we are using minimum priority queue, so we will give the highest priority to the node which have the minimum distance from node 3. So now here I am going with 2, 1 and then 4, 1. You can write 4, 1 and then 2, 1. It's same thing because both have the distance 1, and then we have this 5, 2. Now 3 is done, we have added its connected nodes also, so we will mark visited to 3, and then we will move to a next, like we will pop the next node from the priority queue, that is 2, and then we will see 2 is not connected with any node, like 2, it doesn't have any directed signal to any of the nodes, so it's not going to provide signal to any node. So we will find the minimum distance from 1 and 0, that is 1, so we will update this by 1 and mark 2 as visited, and then we will pop the next node in the priority queue, that is 4 comma 1. For 4 comma 1 it is directed to 5, but the distance it will take is its distance, that is 1, plus the reaching from 4 to 5 distance, that is 1. So we will add that is 5 comma 2. So it cannot provide signal to any other node, it was just connected to 5, that we added in the queue. So we will mark 4 also as visited, and now we will move to 5 comma 2. We will pop this out. 5 can send signal to node 1, and with a distance 1 from this, and 2 it is like coming from 3 and 4, and then it's reaching 5, so 2 and 2 plus 1 is 3, so 1 comma 3, this is 1 comma 3. So this is 1 comma 3. So now the total maximum distance is 2 or 1 is 2. So we will update this total time, mark 5 as visited, and then again we will pop out this element, this is 5, and then we will see it's already visited. So we will move to 1. We will pop out 1. We will see the maximum distance 3 and 2. We found that 3 is the maximum distance. We will write 3, and then we will add the children. I mean, in the sense children is like 1 can send signal to 6, so we will add the node 6, and the time it will take is like 1 of this is 2 from reaching from 1 to 6, and the other is 3, so total is 5. So we will mark 1 as visited, and this is 6 comma 5, so 5 is the, so for 1 we are done. Then we will pop out 5. For 5 it cannot provide signal to any node, so we will just see the total distance, that is 5, and the 3, like 3 or 5, which one is maximum, 5. So we will update this by 5 and mark 6 as visited. Now we have visited all the nodes, and the total time which we got is 5, that is what we have to return it as the answer. So now let's code it up. First thing what we will do is, we need to create a class. Why we need to create a class? For this mapping. This is like the target node and the distance or the time it is taking, and this is the integer, or basically for that, like we will build a graph. So what we will do is, we will create a private class, let's name it as node, which will have the two variable. One is the target, because in this question it is mentioned like v is the target node and wi is the time taken, so target, and the other is the distance or the time taken, we can say. And then we will create a constructor, the first thing is, I have written a spelling wrong, it's TAR, and then target, and this dot distance is equals to distance. First thing what we will do is, we have to create a minimum heap or the minimum priority queue. So priority of type node, we will name it as PQ. Priority queue is of which type we want, that it should give the highest priority to minimum distance. A dot distance minus P dot distance. So this we have created a priority queue. Next thing what we will do is, we will create a map of integer comma set of node, which will have graph or the build instance, and we will provide here the times array. And the other thing is we need to create a set of integer which we will name it as visited. We will add the element those who are visited in it, hash set. This we are done. For graph, what we will do is we will create a method of type map and we will name it as build graph. Our input is the array, times array, and then we will check for integer array of time times map dot put if absent what time of 0. We will initialize with new hash set. Otherwise map dot get time of 0, and we will add what? We will add time of 1, that is the target and the distance. But here we have not created any map, so first we will create a map. So our build graph is ready. After this, what we will do is first thing is in the priority queue we will add which will have this source node, and from source, that is this and the target node, and the distance is 0, and then we will create a variable total time, that is what we have to return. And if we didn't get, then if there is one node left also and we couldn't, and the signal couldn't reach there, then we will return -1. For example, if for now 1 is directed to 6, if in any case if this direction would be this, from 6 to 1 we can never reach to 6, then we cannot, from 3 we cannot give signal to each and every node, and in that case it will return -1. Okay, so that what I have mentioned over here. So we will return -1. But before this, what we will do, we will create, as we are doing the BFS traversal, the basic one. If this is not empty, what we will do, we will take out its size, that is pq dot size, and then we will create a loop while size is greater than 0. Then what we will do is we will create a node head and we will poll from it, and then what we will see is if visited contains head dot target, if it's already have its target node present, we'll just continue. Neitherwise we will add head dot target, and the total time, we will update the total time, that is mat dot max of total time, compare it with the head dot distance. Now we will check if our visited dot size is equals to n, that means we have visited all the node, then we will just return total time. Map dot contains, we will check, so if map dot contains head dot target, then we will add its children. So for node, let's say children, or the other node which it is connected to, like 2 can send signal to 3 and 1, so in this case I'm calling this 3 and 1 as children. So we will get this from map dot get head dot target, and we will create integer, that is children time. So this is equals to what? This is equals to the children distance plus what? The head distance, and then we will add this in the queue. pq dot offer new node which will have the children dot target comma children time, and we are done. Let's run it. Thing is, we have to use here contains key, and the other thing is we have to add this, it's in the node, in the constructor, so it's of type node, and we are missing this over here. Let's run it now. It's working. Let's submit it. We are done. Thank you.